Hello, so this is our lesson about the Micromotion Studies. So what is Micromotion Studies all about? Uh, it is concerned with the operations with very short cycles and repetitive cycles. Okay, what are those operations? Watch this video. It is an example of such operation.
Cheesing with a little soul, surpassing all goals. And when the time comes, Monahan said.
So such operation need greater details to analyze for saving motions and effort. It is used in planning for lesser fatigue of the worker because he is doing repetitive motion. So the goal of this study can be achieved through micromotion. Okay, so that's the application of micromotion study. So micro means small. Thus here we study the motions in terms of turbulence. Remember the turbulence that we discussed last meeting? They are reach, find, etc. Okay, so such a study involves the use of film and video when operator performs the job. Why? Because such video will be used later on to be run slowly through a projector, and frame by frame analysis of the work can be carried out. Okay, meaning to say the video will be played in slow motion for a better analysis of motion. Film provides greater flexibility of filming and playback speeds, whereas video is easier in use. So when you use a video, you can always manipulate the movement, the scene for you to analyze. Okay. Now let's try to slow down or make the video a while ago in a slow motion. Okay, so that we can better analyze it. So we will set the playback speed at 0.25 speed. There you notice that you can easily analyze the movement. First, he will preposition his arm to get another box. Okay? And then he will grip. So there we are identifying the techniques. Grip and what next? Grip and hold. Okay? Then prepositioning again. And prepositioning again. So you will analyze it by making it slow motion. Right? So next is the steps. Steps in conducting the micromotion study. Step 1 is filming the job. Second is analysis of the film by slow motion and presenting the data facts graphically through what we call as SIMO chart or the simultaneous chart or the simultaneous motion chart. So here is the example of a simultaneous motion chart, okay, or the SIMO chart. Yan, SIMO chart or the simultaneous motion chart. Okay, so it is in the form yan, of a form. Okay, just like the flow process chart. Here you will write the operation, example, assemble of clamps and bolt. So what part of it, what part number or part code, the operator name. Okay, so analyst, the one who is conducting the micromotion study, the method if it is present or proposed, just in circle, and the date, and of course the summary for the left hand and the right hand, the effective time and ineffective time. Where do you find this effective time and ineffective time? As you remember, we had classified our turbulence in two classification. The first is the effective time, and the second is the ineffective time. Right? So that's what it is your basis, okay, for recording here. So overall, we will just total this time. They are in seconds, so cycle time, their total, okay. So 13.50, because the total of left hand is 13.15, the total of right hand is 13.50, okay. So next, the sketch of the workplace. So here you will just sketch a schematic diagram of the settings in the workplace, okay. So assembled units, here the assembled units, for example, and the U-bolt, the nuts, the clamps are pre-positioned here, and you have an opening here for the worker to do his job, 35 centimeter, okay. So here you will see the column of the left hand description, and next to it is the column of the symbol of the third league. What is the symbol of re? The symbol of re is reach, G is grip. So the M is for move, okay, place a bolt, you will move, and P is for positioning or position. RL is release loaded. So you will notice that these symbols are the third leagues and the corresponding time in seconds. Okay, so for the next group of columns is for the right hand. So here are the steps, and here are the symbols, and here are the time in seconds. So they are simultaneous. Okay, so you have to record each movement and classify each third leads to be used. Okay, so hold the bolt there. So continuous. It will continue until the process is done. Okay, then you will summarize all here in the summary, the time, the total cycle time, right? So for the equipment you need a camera, a film. Nowadays we don't have a film because your camera can record digitally. Okay, so you can use your high-tech smartphones. So microchronometer. What is a microchronometer? It is an instrument for measuring very small intervals of time, also called as chronoscope. So here is the example of microchronometer. Okay, so nowadays it is called as stopwatch. Next, we have the exposure meter. What is an exposure meter? In digital photography, exposure meter is an instrument for measuring the amount of light. So it measures the amount of light falling on or being reflected by a subject, and usually equipped to convert this measurement into usable information, such as the shutter speed and aperture size required to take reasonable photograph. So this is the exposure meter. It measures the amount of light that is very usable in photography. Next, we have floodlights. These floodlights are synonymous with spotlights. Those that are so bright, okay, that you will not, that is used for emphasis of a subject. So reflectors. Reflectors are those that comes in conical fixture that you see in film, right? So they are reflect. There you have it, the reflectors in photography. Next, we have the tripod for holding the camera and the projector, and etc. All other equipments. Okay, so video camera plus its accessories for filming operation. Nowadays, you can use your smartphone because it is very high-tech when it comes to camera, capturing images. So what are the advantages of micromotion studies over direct observation? Okay, so because micromotion studies can be done by direct observation. Greater details are made available because you will acquire more details by using micromotion studies, and more accurate, of course, easier in data collection. Okay, so because you will just film. Better for record keeping, because you can always save what you have filmed. Help in work study personal's development. So why would it help in work study personal's development? Because by studying the micromotion condition of the worker, it helps the personnel to develop an understanding of what is the work is all about. Okay. So next we have the film analysis. Okay. How do we analyze the film? So film is run on a projector or a big screen. If you have a flat screen smart TV, you can use it. Just make sure it is big so that you can analyze every movement. So details of the work cycle are identified in terms of third leagues. Okay, first for left hand and then second for right hand. So this is the general rule. Start with the left and the right hand. So time. What is the time? In wink. So its units is in wink is noted from the chronometer readings of the film for each third league. So sa chronometer readings, its units is in wink. Okay? So 1 wink is equal to 1/2000 of a minute. So that is very fast. Okay? As fast as a wink. That's why it is called a wink. So this one is the same with the above. So I prefer the above form. Okay, when I told you to make a Simo chart, use the above. Okay. So and the units I will recommend seconds. Just don't don't use wink because you don't have a chronometer. Okay, so just use seconds because you will use your cell phone for stopwatch. Okay. So next we have Micromotion analysis. It was introduced by Mandel. Okay. So Marvin E. Mandel at Purdue University, who was first to save film material while planning studies on kitchen work. Okay, so in kitchen work, it was its first application. So Micromotion, it is a special type of micromotion study, so it's under micromotion study, in which activities are filmed at much slower speed. Okay, you will just lower the speed at 60 to 100 frames per minute. So it is very slow, okay, at longer intervals than normal intervals, being between 0.5 to 4 seconds. Okay, so much slower. Thus, a general pattern of movements can be obtained. Avoidable motions can be identified. This one is applicable to very fast motions or movements. Okay. So an example of work that you can use Micromotion is like this. So she notice is very fast. Okay. It seems that it hits the table so much. Right? So you can slow it down in much slower speed. Okay. So you notice there that the repetitive motion. So bingo. So here are the steps for the under Micromotion study. Study the operation to be filmed, prepare the film, analyze the film, develop a better method. Advantages: more economical, less film consumed, and long sequence of activities can be recorded. Of course, you can record as long as you want. Okay. So applications: teamwork studies, material flow studies. Okay. So here you will work with team. Okay. For coming up with better proposed process. And material flow studies. So the material, you can propose a process by the material point of view, like the baggage movement at the airports, long cycle job studies. So those jobs that have long cycle, you can minimize it and become short cycle. And study of artificial limbs motion. Okay, it is under the medical studies. Okay. Next is the cycle graph. So what is this? It was introduced by Gilbreth. Okay, it was a photographic record of the path of the movement of the operator doing a job. So here you are recording the path of the movement of the operator. So little source of light bulb is attached to the hand or finger or any other body part whose motions are to be analyzed. So a little light bulb will be attached to the body part whose motion is to be analyzed. When he or she performs the operation and photograph is taken continuously, the path of motions is recorded on the film as continuous streak of light. So by the continuous streak of light, you can analyze the operator's motion. Okay. So here is the last slide. So the chronocycle graph. It is a special type of cycle graph in which the light source bulb is suitably interrupted electrically. So it is interrupted electrically so that the path of motion in the photograph appears as a series of pear-shaped spots. So you notice these are the pear-shaped spots instead of a continuous streak of light. So instead of this continuous streak of light, here in the chronocycle graph, it is a series of pear-shaped paths. Okay, so this is the direction of the motion. Okay, from the curve to the pointing side. Okay, this is the or the direction of the motion. So the point and end of the pear shows the direction of movement. More elongated and spaced pear spots indicate higher speed of operation. Okay, it helps in studying the complex and restricted motion. So there you have it, our last slide. Hope you learned something new. Okay.